Hello viewers, in this video I would like to discuss two examples of Regula-Falsi method. First example is find a root of 3x plus sin x minus e to the power x. It means here fx is given, that is 3x plus sin x minus e to the power x. Now first step is that we have to find out an interval in which root of this function may lie. It means we have to find an interval where function changes its sign. So we try it by hit and trial. Let's take x is equal to 0.3 and 0.4. The value comes negative and positive respectively. You can see here function value at 0.3 and function value at 0.4. So you may have totally different interval, or you may have one end say 0.3 or 0.4, another end may be different. But once you get an interval, you may apply Regula-Falsi methods formula. So let's apply Regula-Falsi methods formula, and here this is the formula where x2 is the new approximated root, x0 and x1, fx1, fx0 we have already calculated here. So now we substitute all these values. X0 is 0.3 and x1 is 0.4, and corresponding values of function also we have substituted. We got the value of x2 as 0.3612. Now we calculate function value at 0.3612. We see it is positive. It means we got another interval, so we can apply the formula again. So we Next example is find the root of equation 10x plus 10 hyperbolic x is equal to 0 which lies in the interval 1.6 and 3. Correct to 4 significant digits using the method of false position. Here we have been given the function, that is 10x plus 10 hyperbolic x is equal to 0, and the interval is also given, that is 1.6 and 3. But this is quite large interval, so we try to reduce the size of the interval by again hit and trial method, and we see that interval, the new interval, lies inside this interval. So we take value of x as 2.35, function value is negative on this, that is minus 0.03. We take another point 2.37 and see function value is positive. So of course here one root lies between 2.35 and 2.37. So now we use Regula-Falsi method and try to get the new approximated root. X2 is equal to, this is the formula, standard formula. We take x0 as 2.35, we take x1 as 2.37, and fx1, fx0 we have already calculated. We substitute the values and get the value of x2, which comes 2.365. This is the new approximated root. Now we check function value at this point, and this comes negative. It means our root now lies between 2.365 and 2.37. This is the new interval, and we apply Regula-Falsi method again to get new approximated root, that is x3. Now x0 has been replaced by x2, x1 is same, and we substitute all the values again here, and then see the value of x3 is 2.365. so we can stop here because our root is correct up to 4 decimal places.